Welcome everyone, and thank you for tuning in to this online short course on hygienic design. I am Karen Blako, Food Safety Specialist at Commercial Food Sanitation, and I'm kicking off this course by talking about hygienic equipment design in specific. Roger will introduce you to hygienic facility design, and last but not least, Carrie will talk you through hygienic design of utilities. Enjoy! The aim of this module on hygienic equipment design is for you to recognize how important and impactful hygienic equipment design is to food safety. And by sharing and talking through some examples, identify some design challenges. You will also gain understanding on why hygienic design is an integral part of a sustainable food supply chain. Let's take a look at what makes hygienic design so important. The picture shows a kid's drinking cup, which is commonly available in many countries around the world. And possibly you're wondering, what does that have to do with hygienic design? Well, in 2016, pictures appeared on Facebook posted by a parent whose child was continuously getting sick. After some investigation, the parent found that a valve, which is part of the bottle, had mold growth on the inside. The mold growth was only found after physically breaking the valve open. So without compromising the part, you cannot see any soil that is left inside, let alone clean it. The fact that growth can take place inside that part and that cleaning was required was not taken into account at the design stage of the valve. More than 3,000 consumers had reported mold problems with these cups, including 68 cases of illness with symptoms that include vomiting and diarrhea. Due to the attention it received on social media, and it was shared more than 50,000 times, a major recall was initiated by the company. The company realized there were design flaws and worked quickly to address the issue. They redesigned the part and changed the part to a transparent material. Is this the perfect solution? No. Is it better? In some ways, it's better, as any soil or buildup can be quickly detected. The company also realized this was only a short-term fix and not the best solution long-term. It was what they could do quickly and implement relatively easy at the time. They kept working on it and redesigned the valve completely. Now the part is still removable. It is transparent to allow for any soil or buildup to be visibly detectable, and they designed it so it can be dismantled completely to create access for effective cleaning. It is great to see that the company acted quickly at the time and then continued to improve and protect their customers long term. Unfortunately, they had learned the hard way. Let's look at a definition of hygienic design, being the application of design techniques which allow the timely and effective cleaning of the entire manufacturing asset. There are two main points I'd like to highlight. First, the timely and effective cleaning. We want to achieve an effective result, meaning we have achieved the result we need to achieve, and then this also needs to be achieved in a timely manner. Production time is valuable, and we do not want to spend 24 hours cleaning after every shift of production. The second important point is how it relates to the entire manufacturing asset, meaning the entire production room needs to be cleaned, which includes not only the equipment, but also includes the infrastructure, as they are both important. Let's look into microbiology and how this relates to hygienic design. The International Journal of Food Microbiology published a study that concluded that there are no strains of Listeria monocytogenes with unique properties that lead to the persistence to cleaning protocols, and that it is the harbor site in food industry premises and equipment where L. mono can persist and grow, pointing out to us that each strain is equally susceptible to cleaning and that we need to focus on areas where the Listeria can be allowed to grow. On the right-hand side are three pictures from under a microscope that show the same pin as the picture on the left. In the left picture, the tip of the pin looks clean and has a smooth and easy to clean surface. Under the microscope, however, we can see that the pin is covered in bacteria. Although the surface is smooth and the pin looks clean, there are still plenty of bacteria on the head of the pin. This shows us that even though it is visually clean, it might not be microbiologically clean. Equipment will always have hygienic design challenges and flaws, and there will be harborage areas that can easily become an area for microorganisms to grow. Let's look a bit more into equipment design challenges. Before looking at some specific examples, let's first introduce the hygienic design principles for equipment. There are many guidelines for different topics available in the industry, including over 50 from the EHEG, European Hygienic Engineering and Design Group. You can have access to these guidelines when you become a member. And when you're an international company, check with your headquarters first to see if they are already a member. Another institute is the AMI, North American Meat Institute, and they have developed hygienic design guidelines for equipment and infrastructure for high moisture products such as meat, poultry, and seafood. The GMA, Grocery Manufacturing Association, focuses on equipment and infrastructure design for low moisture products. Both AMI and GMA guidelines are freely available on the internet. Shown on the left are the 10 principles listed by the AMI for the hygienic design of equipment, including Principle 1, cleanable to a microbiological level. 2, made of compatible materials. 3, accessible for inspection, maintenance, and sanitation. 4, no liquid collection. 5, hollow areas hermetically sealed. 6, no niches. 7, sanitary operational performance. 8, hygienic design of maintenance enclosures. 9, hygienic compatibility with other systems. And 10, validated cleaning and sanitizing protocols. Each principle has several sub-principles, and when reviewing existing or new equipment with a cross-functional team using a checklist as such, you are able to score all sub-principles. The score includes S for satisfactory, M for marginal, U for unsatisfactory, or NA for not applicable. After the review, the score will help show priorities for design changes, as well as areas for improvement or areas that need focus and require to be included in programs like sanitation and preventative maintenance programs. Now, let's look at some specific examples of design flaws in the field. The picture on the left is from a meat processing facility. The protective cover is fixed to a frame with screws, and the gap between the frame and the protective covers is very small and cannot be cleaned unless the cover is removed. Sanitation will most likely not use a screwdriver every day to disassemble, clean, and reassemble, as it takes way too much time to make it an efficient process. The picture on the right has been taken in a chicken processing facility. The polyethylene conveyor wear strip is tightly fitted into the stainless steel support profile. This design cannot be disassembled for cleaning, and this can become a harborage area for microorganisms which over time can contaminate the product. What about these two pictures? The question is, are these compatible materials? The picture on the left is a fiber back belt, or sometimes referred to as a PVC belt. The surface and edges have worn, and the fibers from the interior of the belt are exposed. When this conveyor belt becomes wet, the water and whatever bacteria is present will be absorbed into the interior of the belt, creating an excellent environment for microorganisms to grow. The picture on the right shows equipment parts that are made from aluminum or aluminium, depending on where on the planet you come from. The material is a soft material that is not very chemically resistant, and corrosion has formed on the surface of the equipment. So in this environment, was that the best material to choose? When equipment is not designed perfectly and has design flaws, how do we get it right? This slide shows a supply chain with focus on sanitation and for the production of safe food. For any project, the sooner the concept of hygienic design is introduced, the better. At the conceptual stage, it is necessary to consider the sensitivity of the product. Will we need to wet or dry clean? What about hygienic zoning, or whether allergens will be introduced? And if we're aware of any defects in existing and new designs. In the design stage, we should consider the hygienic design of equipment. In this step, the cleaning method should be considered, and we need to be laying the ground for cleaning procedures and also understand what utilities we require. During the design review stage, the equipment and facility design checklist should be fully utilized to review the design and adjust or redesign when needed. At the same time, in this stage, it's important to start developing procedures, for instance for cleaning and allergen management, thinking through and evaluating traffic patterns for ingredients, packaging materials, people, and trash. You can see that hygienic design should be considered from the start and throughout the process, all the way through to the operational stage and when actually cleaning the processing area. The earlier in the process things are considered, the easier and more economical it will be to change things. The continuous improvement cycle of hygienic design is just like the PDCA cycle. Plan, do, check, act. Continuous improvement is ongoing, using the design checklist to evaluate the design and identify risks. Then, create a plan that includes how to manage design flaws and design out flaws as needed to improve equipment. Communication with enablers such as engineering and equipment suppliers is key. Afterwards, measure and improve. Measure the progress of what has been implemented and revise the action plan as needed. The next step is to evaluate the effectiveness of the improvements. Have the improvements reduced the identified risk? Are the improvements sustainable? In this step, we must continue to communicate with enablers such as engineering personnel and equipment suppliers. Then return to the evaluating step. Hygienic design is a cross-functional effort, and if not already implemented, you can start with smaller projects and gradually expand. To summarize, good hygienic design starts with awareness. It takes planning, education, and communication. With new knowledge you gain today, you will take different decisions tomorrow. And there are great tools out there like design checklists and guidelines that can support achieving good design. And hygienic design is a collaborative effort of the industry as a whole, and processes as well as equipment suppliers must work together to gradually improve design. Thank you for watching and listening, and I hope that this course will provide you with new knowledge and support you in taking different decisions going forward. Please reach out to us if you have any questions or want to explore things in more detail.